Okay, here are your notes for section 6.4. It's more elimination. We did that in 6.3, where we added down and actually eliminated a variable. But now we have to use multiplication. If you thought maybe 6.3 was a little bit easy, or like, oh yeah, this is nice, it's a shorter process, there's always one more step. You should know that about math by now. So take a look at this problem. 6x plus 5y equals 19. Write it down. 2x plus 3y equals 5. And normally, when we added down, we had 6 and negative 6, or 5 and negative 5. Or if we had a 6 and a positive 6, we learned how to change the signs. Not so in this case. We do not have the same number. So now you're like, oh, what do I do if we don't have the same number? You have to have the same coefficient if you want it to eliminate. So the process is you're going to take the smaller coefficient, this is a 2, this is a 6, and you're going to multiply by 3. Kind of like when you get a common denominator in fractions. How do you turn the 2 into a 6? You multiply the 2 by 3. Okay, now be very careful. This is a positive 6. If we want this to eliminate, we have to make this a negative 6. So I'm going to multiply by negative 3. And when you multiply that by a negative 3, you, like we did with a negative 1, have to multiply this number, which is negative 6x. You have to multiply this number, which is negative 9y. And you have to multiply this number, which is equals negative 15. You change every number in the equation. I can get rid of this now so that I don't accidentally look at those numbers. And from here, adding down will work. 19 plus negative 15 is 4. 5y plus negative 9y is negative 4y. 6 plus negative 6 is gone, eliminated. Always make sure that it worked out right. Take this step, divide by negative 4, divide by negative 4, you find out y equals negative 1. And if you forgot, you have to plug it in to find x. Where do we plug it in? In for y. Y equals negative 1. So we're going to put a negative 1 right there. 6x plus 5 times negative 1. I almost did it wrong. Which is negative 5 equals 19. 6x minus 5 equals 19. Add 5 to both sides. 6x equals 24. And divide by 6, x equals 4. Final answer, put the x first, then your y, and this is the coordinate on your graph. So it's not terribly bad. We've done this before, but we've just multiplied by a negative 1. This time we have to pick a number to multiply by. Let's try it again. Go ahead and write this problem down. 2x plus 5y equals 3, and 3x plus 10y equals negative 3. If you look at the x's and you ask yourself, hey self, what can I multiply by 2 to turn it into a 3? That's not very easy. You could use a decimal or a fraction, but you don't want to turn the 2 into a 3 because that's not nice. How about we turn the 5 into a 10? Those are multiples of each other. That's a nice common denominator theme, or we could call it the least common multiple. So instead of working with x's this time, we're going to work with y's. So I'm going to take this whole equation, ask myself again, what times 5 equals 10? And it's 2. And now look at your signs. If they're both plus, that's not going to work. I want one negative and one positive, so I'm going to multiply by negative 2 again. You don't always have to, but this time you do. Negative 4x minus 10y equals negative 6, and now you get to add down. This is the part that you're supposed to already know from the previous section. So from here you should be okay. 10 plus negative 10 is eliminated. 3x minus 4x is negative 1x, again preferred without the negative 1. But if you show it, you would then finish the problem as x equals 9. Or at least finish that part of the problem. Please don't forget every time to take that x and go plug it in. This time I'm putting it in then for the x. How do you know? Because it says x. 2 times 9 is 18. Plus 5 times y equals 3. Minus 18 from both sides. 5y equals negative 15. And I know, I cruise through these a little bit fast, but that's because I know that you can pause it if it takes you a little bit longer to write it down. Y equals negative 3. Final answer, 9, negative 3. I'm going to do one more. And this time you're looking at it and you're wondering, okay, go ahead, take the time to write it down. Pause it if you have to. Should I multiply this 2 by 2 and turn it, or this negative 2 by 2 and turn it into a negative 4? Or should I multiply this y by negative 5 and turn it into a negative 5? Cool thing about that is it's your choice. On this problem, we didn't want to try to turn a 2 into a 3. That's terribly difficult. On this problem, you don't want to try to turn a 3 into a 5 because those aren't factors of each other. So we picked the 2 and the 6. On this problem, your choice. Go ahead and change the x into 4x or the y into 5y. I'm going to choose the x this time. And if I do choose the x this time, I'm only going to multiply by 2, not negative 2, because I already have opposite signs. So if I multiply that, I get negative 4x plus 2y equals negative 10. Add down, 3 plus negative 10 is negative 7, equals, equals, equals. And if you want to, again, you could scribble out this middle so that you're looking top to bottom. 5y plus 2y is 7y, and make sure that you have a positive 4x and a negative 4x for elimination. Divide by 7, y equals negative 1. Take that negative 1, make sure it goes in for y. 5 times negative 1, you get 4x. Minus 5, because 5 times negative 1 is negative 5. 2 steps, add 5 to both sides. You get 4x equals 8. Divide by 4, and you get x equals 2. Final answer, 2, comma, negative 1. That's it. Those are your examples. I'm curious, though, if anybody has ever thought, like just in seeing these, well, what if you can't multiply it? This, I was able to turn the 2 into a 4 or the 1 into a 5. This one, I was able to turn the 5 into a 10, but not the 2 and 3. Same thing on the first one. What if this doesn't happen? I can't turn the negative 3 into a 4. There's no whole number or integer that I can multiply. Same thing with 2 and 5. I would need an even number up here. So you might be like, oh, I guess I just can't do elimination. I'll have to do substitution. There is a method for another time, probably Algebra 2, or maybe if we move on and we can do one more day of this. What if I will show you and I'll set it up, but we don't need to actually solve this in this lesson. But some people are actually curious. What would you do? I would look at these two x's and say, okay, if 3 doesn't go into 4, what do they go into? It's no different than when you used to have to do common denominators. You didn't turn the 3 into a 4, you turned them both into 12. Remember when you did common denominators and fractions? Same idea. 3 and 4 both have 12 as their least common multiple. So I'm going to multiply this one by 3. And I'm going to multiply this one, I'll go a different color, by 4. And when you do the first one, you'll get 12x plus 15y equals 105. When you do the second one, you get negative 12x plus 8y equals negative 36. And believe it or not, look at there, you've got elimination. Add down, add down, add down. You would just solve it from there. But again, no problems like this on your assignment today. It's just a what if this happens, it still can be solved. But we're going to stick to at least one of them can work, and you just have to multiply one time instead of 2. So, good luck with this assignment. I've got writing all over my face. Let's try it like that. Good luck with this assignment. If you get some really ugly, awful fractions, go back and check your negatives because there shouldn't be any. Good luck.